playing from the current slide. So welcome back to the nomenclature show. We are now going to go the other direction. So the principles are the same going the other direction. So it should go a little bit more quickly for you, hopefully. Oops, time I move that mouse. So same flow chart, but now we're going to go from the formula to the name. So it's backwards. So once again, three types of compounds: ionic, covalent, and acids. So if we'll do, how can we tell from the formula? Okay, it's a little bit easier because the formulas have the symbols. So from the formula, you look for the symbol of a metal because an ionic compound is going to have either a metal or a polyatomic ion. All right, so if it doesn't have a metal, it could still be ionic if it contains a polyatomic ion. So how do you know that? Well, first of all, the best way is recognition. You memorize those ions. Until you get to that point, realize that all the polyatomic ions, poly is a prefix meaning many, have more than one atom. That means any compound is going to have at least 3 elements. Just be careful because if it begins with H, it's an acid. Right? So again, all of these are ionic, and what's in bold will tell you how do you know. Iron is a metal, it's ionic. The compound that lives next door, your neighbor, jokes just don't work the same if I'm not in class, right? All right, so sodium is a metal. Again, a metal and a polyatomic ion here. A metal, polyatomic ion, metal, polyatomic ion. Here's 2 polyatomic ions, but also just count the capital letters. Okay, again from the formula, how do I identify if a compound is covalent? You're going to look at the formula again, and remember covalent compounds are 2 nonmetals. So any compound made from 2 nonmetals. Also, they may have those prefixes like mono, di, tri. So again, 2 nonmetals, 2 nonmetals, 2 nonmetals. Therefore, they're covalent. Remember, you have to do that step first because if you don't do that, you're going to go down the wrong path. How do I identify from the formula that a compound is an acid? Pretty much it's going to begin with H, except for water, H2O, and hydrogen peroxide, H2O2. But you're not going to deal with hydrogen peroxide very much. All right? So that's the identification step. These are all acids. Now, I'm not going to click on the answer slides, but you can certainly do in the home version. So MOF6, okay, MO is a metal. So this is an ionic compound. CaCO3, Ca is a metal. That's a polyatomic ion, another ionic compound. What do you think this one is? That's a hint. It's an acid. And again, carbon and selenium, 2 nonmetals. As far as metalloids go, you can treat the metalloids and just look at what side of the line they're on. All right, now, to name ionic compounds, what we do is we name the ions. So the ionic compounds, they don't have the word ion in the name. So you wouldn't say barium ion, chloride ion, you would just say barium chloride, but you name the ions. So again, 4 types of ions. There's the representative metals, the same types that we did before. This gets a little tricky, so I'm going to go a little slow in part of it. Same flow chart. All right, so the flow chart does have going both ways on it. So we've determined it's ionic. How are we going to come up with the name from the formula? So the representative metal ions, again, group 1, 2, 13, zinc, cadmium, and silver. You don't have to worry about the charge because you already have the formula. You just call it the name. So Ba is barium, aluminum, zinc. If it's by itself, meaning it's not combined, you would say ion, but otherwise you don't. Those are the easy ones. So this is called sodium, cadmium, strontium. All right, again, you can click on the answer slides if you're just going along with the regular PowerPoint. I'm not going to do that in the video every time. All right, now the transition metals are tricky because if you recall for the transition metals, they form more than one ion. So you have to come up with the charge, right? Because the charge is going to be in Roman numerals. So you're going to have to say iron 3 or cobalt 2 or molybdenum 6 or something like that. So how are you going to figure out the charge? All right, this is the nomenclature piece. So the charge you might want to review Roman numerals, right? Iron 2 with a 2 plus, it's iron 2, and so on. So we went through that before. It's the same slide. So first of all, you know you have to do this because it's not in groups 1, 2, 13, or zinc, cadmium, and silver, any other metal. Okay, then how do we figure that out? Well, the nice thing is you can always figure it out because you have the formula, and that means you know the charge of the other ion. Because of the 4 types of ions, 3 of them you can get from the table, or if it's a polyatomic ion, this is the only one you can't. So you have to work backwards. You can read through this, but let's say we have this compound, FeBr2. Whoops, FeBr2. Whoops, wrong way, sorry. FeBr2. We need to come up with a charge on the iron. It's going to be called iron something. So we look at this, we have iron with some charge. Bromine, however, is a nonmetal in group 7, so it's a -1. I'm sorry, group 17, so it's a -1. From the formula, we know that there's 2 of them. That means there's 2 negative charges. If there's 2 negative charges, there have got to be 2 positive charges. There's only 1 iron. We know that because there's from the formula. That means that iron must be a +2 charge. Okay. So try these on your own. All I'm asking you to do here, come up with the charge. This is going to be vanadium something, tin something. So once again, hit pause. Try it on your own. All right, you're back from pause. So I've gone to the answer button. So again, this is going to be vanadium something. So we look at this, but the other ion, I'm stuttering now. The other ion is phosphate. We know phosphate's a -3 because it's a polyatomic ion, and we looked it up. In my case, I looked it up in my head. Right? We also know that there are 5 of them because it says so right there. That means that there's 15 negative charges. If there's 15 negatives, there've got to be 15 positives. Those 15 positives come from 3 vanadiums, because right there, from the formula, that means the vanadium has to be a +5. 15 divided by 3 is 5. So that ion is going to be called vanadium 5. For the tin, in this case, Sn is tin. It's going to be tin something. Again, it's not in group 1, 2, 13, or those other 3, zinc, cadmium, and silver. So it's tin something. Carbonate, though, CO3, we know is carbonate. Right? So CO3, we know that there's 2 of them from the formula. We know its charge is -2. That means there's 4 negative charges. That means there have to be 4 positive charges. 4 positive charges come from 1 tin. It means tin must be a +4 ion. Okay? It's a little tricky, but it's not too bad. Most people, the problem they have is not doing it, is that they forget to do it. That's why you got to do those steps. All right? That takes care of those types of ions. Let's do the nonmetal ions. All right. So the nonmetal ions, then they just end in "ide." So O2 minus is going to be oxide. P is phosphorus, phosphide. I is iodine, iodide. Where do you truncate it? Why isn't it phosphoride? You know, there's some weird rules about that. In my case, I'll correct that, but make sure you have the suffix correct. The suffix is important. If you cut it off in a weird place, I'll correct it and not take a point off, but you need to get the suffixes right. The other stuff is important, but the suffix is more important. And at this stage of the game, that's how we're going to roll on it. All right, so this is arsenic. I'm not going to click on the answers, but I'll give you, hit pause, try it on your own. Okay, arsenic, so arsenide. Sulfur, sulfide. Fluorine, fluoride. All right? That takes care of ionic compounds and naming the ions. So now we'll go through naming these. We're going to come up with the names. So we've already done the step in this case determining their ionic because it says name the ionic compounds. So let's just go through these. I'll walk you through these. Then I'll give you some to try. You can hit pause. All right. So SRI2. SR is a representative metal. It's just called strontium. I, nonmetal. iodide, right? Iodine, iodide, so it's just strontium iodide. We don't have to do anything cute with charges because it's a representative metal. Al2SO43, same idea, aluminum. You look at your periodic table, representative metal, aluminum. Okay, SO4 is a polyatomic ion, sulfate, so it's called aluminum sulfate. Pretty simple. Now this one, Cr2O3, Cr is a transitional metal. That means we need to come up with the charge. O is going to be a non-metal ion, negative, it's a -2 charge, so it's going to be called chromium something oxide. All right, so then we have to go through that process again. We know that oxygen's a -2, and there's 3 of them. Whoops, where'd I go? Oh. All right, we know it's -2 and there's 3 of them, so there's 6 negatives. That means there have to be 6 positives. There's only 2 chromiums. Chromium must therefore be a +3, so right there. So it's chromium 3. So this compound is going to be called chromium 3 oxide. So the number in here is not how many of them, it's the charge. Right, and then the last one, this is titanium. Titanium is a transition metal. This is phosphate, so it's going to be titanium something phosphate. Same process, we determined that the titanium is a 4 charge, so it's going to be titanium 4 phosphate. All right, so why don't you give these a go, see if you can come up with these. Okay, hit pause. All right, you're back from pause. Here we go. I'm going to do this quickly because we're getting out of time here on this set of slides or this part. Calcium, CaCl2, right? So calcium, don't have to do anything with it. It's just calcium, and Cl, calcium chloride. Sr, also a representative metal, strontium. This monster is a polyatomic ion, obviously, acetate, so it's strontium acetate. FeBr2, okay, iron is a transition metal, so it's going to be iron something bromide. Br is bromide. Same process, bromine's -1, there's 2 of them, -2, that means 2 positives, there's only 1 iron. The iron therefore must be a +2, iron 2 bromide. And then this compound, we already went through how to get the charge because I used the same example. It's going to be called vanadium something phosphate. So vanadium is a transition metal. Phosphate is a -3. There's 5 of them. It means 15 negatives, which means 15 positives. There's only 3 vanadiums. 15 divided by 3 is 5. Therefore, vanadium is a +5 charge. So it's vanadium 5 phosphate. All right. So that is going from the formula to the name for ionic compounds. This will be the end of this part. We'll do at least one more.